You are welcome to my channel. This morning we'll be talking about ozonolysis. And where can we find this ozonolysis? They are being classified under the preparation of alkene. And how can we find this word ozones? So we say oxidation of alkene with ozone. Oxidation of alkene with ozone. So now, when we want to give the definition of this ozonolysis, we can say ozonolysis is oxidation of alkene with ozone, which reacts with an initial formation that is very reactive. So let's put it like this. Oxidation of alkene with ozone formed an initial formation that is very reactive and unstable with ozonide, which reacts with a reducing agent, and that reducing agent we have zinc plus ethanoic acid, which we know as acetic acid now. So you two aldehyde and two ketone. Again, ozonolysis of or the oxidation of alkene with ozones form an initial formation that is very reactive and unstable with ozonide, which reacts with a reducing agent, which is this, to yield or to give two aldehyde and what? Ketone. And don't forget that in some cases or in some textbooks, we can classify this aldehyde to be alkene. Don't forget. And this ketone, we call it what? Alkanone. So now, let's take the reaction of this ozonolysis now. So the first thing we are going to have is that we have alkene with alkene, because we are talking about the reaction of alkene with what? Ozone. Plus ozone is going to yield what? Ozonide. And one thing you should note is, if you have something like this now, your answer, when these and these react together, is going to give us what? Ozonide. So now, let's pick a good example of alkene with carbon 4, which is what? Butene. We have CH3, CH, the double bond, which is this alkene. We have CH, CH3, plus the ozone, which is what? O3. So how do we have our ozonide? Don't forget that you have 3 oxygen here, and these 3 oxygen here act as nucleophiles. And how do they act as nucleophiles? Because they are electron rich, so they have a what? A negative sign. So now what we are going to do is that this one you have here now, we have it in this particular position. We have CH3, CH, one of the oxygen, which is this. The second one will be here. To break the double bond you have there and turn it to what? A single bond. So with this now we have another CH3 here, CH. So we are left with one of the oxygen now. So one of these will come here, this, to have this. So we call this one what? Ozonide. You can see it now that if we have an unstable ozonide, which decompose to have a good reducing agent, which is what? Zinc plus our acetic acid, which is known as what? Ethanoic what? Acid now. So now, class, the end product here, we have ozonide, which is this now. Is going to react with water. So with that now, you can say we have this. So we write your ozonide to be in this form. We have CH3, CH, CH3, CH2 plus water. Don't forget that when they react with a good reducing agent, they are going to yield or give what? 2 alkene, which is what? Aldehyde, or what? 2 ketone. So with that, now let's see how they give us 2 ketone. And again, don't forget, you have this. So what's the first thing you have here? We have CH3, C double bond, we have what? H. With this now, don't forget that your water can be split into two. We have a positive here and our this. Here is our electrophiles, while here is what? Our nucleophile. So when this one protonates with each other, are you getting it now? When an initial hydrogen protonates with the ozonide, we are going to have an alkene, which is being classified as what? The aldehyde now. So now with this now, I pick this and this also. We what? Differentiate the two, and this my oxygen here will react with water. Again, this one you have here, this oxygen here will form what? One alkene. This also what? We form what? Another alkene. So the first alkene, the second alkene, telling you that what? When talking about the oxidation of alkene with ozones, it's going to yield, when decomposed, it's going to yield what? 2 alkene or what? 2. So with this now, I have this to be in brackets now, plus, mind you here we have what? Water. Because this, our oxygen here, will be what? Unstable. That is, it has like what? A lone electron. Sorry, a lone element now. So when you are going to have what? This. So here we call it what? Peroxide. So you can see now, that's the ozonolysis now. So let's take the last reaction of this now. And when we have to take the last one, we are going to pick a good examples now, which is this. We have CH3, C, H double bond. We have our C what? CH here. So now, don't forget now, this one, or let's pick the one we have here. Should we to continue with this, or we should pick that one we have there now? So with what you have here now, it's telling you that if this, you have CH3 here, the next thing to have will be what? Ozonide, which is this. Are you with me now? So, now let's introduce our reducing agents. Now, we have the zinc. Sorry, the first thing I'm going to have here water because we make use of water here. Then next we have zinc plus CH3 COOH. So now, don't forget that our end product must give us what? A ketone and what? An aldehyde. So with that now I can say that I have CH3 C double bond plus, you can see it now. From that ozonide now, I pick this one here to react with what? One of these oxygen to give us what? A ketone. So what you have here now, we have what? C, we have double bond AH here, we have CH3. We can see now, we have do just that when an alkene reacts with these particular reducing agents now, it's going to yield what? A ketone and aldehyde. And before we end this class now, let's go back to this particular mechanism here. This peroxide here, when oxidized with a carboxylics, again, when a peroxide oxidized with a carboxylic is going to yield what we call what? A peroxide. And that peroxide can be classified as a peracid. That is the oxidation with what? A peracid. And note one thing again, when ketone and aldehyde readily or can be identified, again, when a ketone and aldehyde can readily or can be identified with their physical properties, is going to give us a what? A crystalline derivatives. Telling you that for every alkene or for every butene, for example, under the alkene, is going to give us what? Either 2 alkana or what? 2 alkanone. That is the ketone and the aldehyde now. So class, with this now, I've explained in detail what ozonolysis of an alkene is. And don't forget that the oxidation of ozone, the oxidation of alkene with ozones form an initial formation which is very reactive and also unstable with ozonide, which decompose to give us or to react with a good reducing agent, which is what? The zinc and the acetic acid, which is what? The ethanoic. And don't forget that I tell you guys that in oxidation of a parasite or a para-acid, oxidation of a para-acid, that is, if any peroxide now reacts with any carboxylic, is going to yield what? A epexo oxide. Thanks guys. Don't forget to subscribe, share, like the slide, and what? Comments. Thanks.